Hey guys, welcome back to my channel and this is Varun Tahin. In the previous sessions, we looked into standard normal distribution and how it is perfectly applied in the real world cases. We also saw that it is simplification of normal distribution when Z scores are taken into consideration. Now we will extend that thought and see how central limit theorem supports the concept of normal distribution. But before that, we will deep dive into the terminologies associated with CLT or central limit theorem. So first we will see what sample means and why they are used, then some of its terminologies, then what sampling distribution is, and then central limit theorem and the error estimates using CLT. Now, as we have seen earlier, samples are used when conducting the experiment including the large population. So among the large population, we will take a subset of some population sample and we will conduct experiment on that. Examples can be seen that average number of time people in urban India visited malls last year. So let's say that 10,000 people went to malls last year and we have to do a survey on that, asking people how many times they visited the malls last year. So we cannot do it for all the 10,000. So in that case, we will take a sample of some small amount, which is also feasible for us to collect the data. The other examples we have also seen this sampling for average daily commute time. So let's say that the entire office has 30,000 population. Now mean can be taken as mu for that total population, and among that we are considering only 100 employees, so this becomes the sample for which the mean is x bar. Now samples can be also error prone. The reason for this is the characteristics of sample population and those of a general population is different, and these arise because sampling sizes are inevitably limited and it is impossible to sample an entire population in a survey or a census. Now we have to understand some of the terminologies mentioned over here before we reach out to central limit theorem. So this table is separated into two parts. The first part is the formulas pertaining to population and the second is pertaining to samples. So from now onwards, we will regard the population size as n, which we already know is the number of items or elements in the population. Now population mean will be always mu and it is calculated by summation of the individual elements starting from first element till the nth element divided by n, and the population variance is sigma square, which is calculated like this. We will take a difference of each of the individual elements from the population mean, square it, and take the summation of all those calculated values starting from the first element till the nth element and then divided by the population size. Now coming to samples, so sample size we will denote it by small n, which is the number of items or elements in the sample, and sample mean will be x bar, which will be calculated just as the population mean, but instead of taking the population size in the denominator, we will take the sample size instead, and then the sample variance. So sample variance is denoted by capital S square, which is again calculated just like population variance. The difference is that instead of having population mean as the subtractive value, we will have the sample mean as the subtractive value over here, and the denominator will be n minus 1, which is the sample size minus 1. Now this is a complex logic, so this is out of the scope of this session, but just remember this guys, that in case of samples this will be n minus 1 always. Now that we have learned about some formulas on population and samples, let's do some exercise on this. So let's say that we have some sample of student. Okay, so these are 5 students for which we have their height according to their roll numbers, and we have to calculate the sample variance of this sample. So guys, if you can recall, the sample variance is denoted by S square, which is summation of all values of xi minus x bar square divided by n minus 1, where elements are starting from 1 to n. Now as we will be doing calculations by height, so let's denote it by x. Now what we have to find first is xi minus x bar. Okay, so for this we will calculate the sample mean first, which is the summation of xi divided by n. Now if you add these values, you will get 698.44, and as n is 5, that is we have total of 5 students as sample, so n will become 5. So this will come as 139.688, or we can say approximately 139.69. Now what we have to do next is subtract this value from the individual elements, that is 121.92 centimeter minus 139.69, which will be minus 17.77. So likewise, we will calculate for each of these elements. Now once we have calculated this value, what we have to do is we have to do its square. Okay, so this will again be calculated as okay. So we have all these values ready. Now we have to put this into this equation. Now when we do a sum of this, it will come to 1841.255. Okay, so let's put this value over here, 1841.255. And guys, remember that we have to do n minus 1. So n here is 5. So 5 minus 1 is 4. So this will be 460.313. Thus s will become square root of 460.313, which is 21.45. Now let us understand the concept of sampling distribution. So sampling distribution helps in estimating the population mean from the sample mean, right? So let's say that we have a sample population and we are calculating its mean, and now we want to approximate the value of that mean to the population mean. Okay, now this is denoted by range of values. Okay, so let's say that we have calculated the sample mean as 36.6, but during calculation of the population mean, we have to consider some error value or some correction on top of it, because this is not exact. So this means that the population mean can lie 3 point ahead or 3 point below the sample mean. Now if the average or mean is like 36.6 plus or minus 1, we can be sure that average can be 36.6. But if average or mean is 36.6 plus or minus 10, this correction is a huge value, and thus we are not sure that average is 36.6. So we need to have some mechanism of calculating this threshold, which is plus or minus x value, which is permissible, and if we consider this value, we can say that population mean lies in this range. Now let us understand the meaning of sampling distribution with the help of example. So do you remember the 5-ball game we have played earlier? So let's take that same example. Okay, let's say that out of 75 employees, we are taking 5 samples up to 100 samples, and we are distributing the value of sample mean in a graph versus the probability density. So the graph we will get out of this will denote the sampling distribution over here. Got it? So in short, the sampling distribution, specifically the sampling distribution of the sample mean, means it is a probability density function for the sample means of a population. So it is further sample of a sample. Okay, and it is denoted by mu of x bar. So this will help identifying the sampling errors as well. So the reason of this denotion is because sampling distribution mean is the mean of the sampling means. Now these are some of the properties of sampling distribution. So first one is it can estimate the errors in the samples. Now this is done because we are taking a lot of small samples and we are calculating its mean and plotting it. So that is the reason we can calculate a estimated error on those. The second is it is denoted by mu of x bar, whereas population mean is mu. And third and the most important is as the number of samples taken increases, the sampling distribution mean equals the population mean. So you can see this graphs drawn below. The graph is wider when we are taking small samples, that is where n is equals to 5, and it becomes more narrower when we increase the sample size, that is where n is equals to 20. Now the reason for this is as taking large number of samples removes sample bias because it accommodates the diversity of individual values, and in the second graph there will be lower number of squared errors values that are more concentrated in the middle. Now let's look at some of the formulas related to sampling distribution. So as we know that mean of sampling distribution is denoted by mu of x bar, and as number of samples increase it will be approximated to the mean of the population. Now there is something called as sampling distribution standard deviation, which is also the standard error, and this indicates how far apart sampling means will be, and this is denoted by sigma x bar and calculated as such: standard deviation of original population divided by square root of the sample size. Now if SE is higher, then values will be farther apart, hence broader curve we will observe, and if SE is low, we will observe a narrower curve. So more narrower it is, the sampling mean will be closer to the population mean and the approximation will be more accurate for us. Now basically the findings which we have got from sampling distribution is what defines the central limit theorem. That is, the sampling distribution mean equals the population mean when the sample size increases. The sampling distribution standard deviation is sigma by square root n, and for n is greater than 30, the sampling distribution becomes normally distributed. Now these properties hold true provided the higher number of samples. Okay, as and when we take a lot of samples and calculate their mean, then these properties will hold true. And in any distribution, we can take mean of its samples. It will be normally distributed. Now let us look at one example and solve it using what we know already. So let's say that you work in a news agency which is conducting an exit poll for Municipal Corporation of Delhi elections. And we have been asked with predicting the winner for Ward 75N. Now we asked 100 randomly selected voters from this ward to name the party they had voted for. And we have collected the data in this table with the contesting party and the number of voters. Now from this sample we have to estimate the percentage of voters that might have voted for BJP. So you define X as the proportion of people that voted for BJP. Okay, so this becomes X. So there will be a different table for this, okay, where we will have X and the frequency of the votes. Okay, so 1 we will denote for the BJP and 0 for any other party. So right now we have INC. Now for BJP we have 58 votes. So the frequency here becomes 58 and the frequency for others becomes 42. And then we have to find the mean of X. So mean becomes summation of Xi by N. Now Xi here are different. So it will be 42 times 0 plus 58 times 1. Okay. So it will be something like 0 into 42 plus 1 into 58 divided by n, which is 100. So we will get 0.58. Now as per the question, we need to find the standard deviation also. So for this, what we'll do is we have to calculate the sample variance first, which is S square equals to summation of Xi minus mean square divided by n minus 1. Now when we look at this closely, for INC it will be 0 minus 0.58 whole square into 42 times, because all the entries of 0 will have a subtraction of the mean and will be squared and multiplied by the number of entries, which is 42 in this case, and that will be summed up with the number of entries for which BJP is the voting party, which is 1 minus 0.58 whole square into the frequency of BJP vote, which is 58, and this will be divided by 100 minus 1. So this will sum up to, so the variance becomes 0.2460, and therefore S will be square root of this value, which is 0.496 or 49.6%. Now let's say that you define Y as the proportion of people that voted for INC party. Now clearly the mean will be 0.42. Okay. Now what we need to find is again standard deviation of Y. Now there would be 42 people for whom Y would be equal to 1 and 58 people for whom Y would be equal to 0. Correct? So we have drawn this frequency table. Now hence the sample variance will become S square equals to 1 minus 0.42 square into 42 plus 0 minus 0.42 square into 58 divided by n minus 1, which is 100 minus 1. Okay, so this will be 24.36 by 99, which is 0.24606. So this is S square. Let's find out what is S. So S will be square root of 0.24606, which will be 0.4960 or approximately 49.6%. Now let's say that we actually took some more samples, each of size 100, and made a sampling distribution of X, the proportion of people that voted for BJP. Now the mean of this sampling distribution is mu of x bar, which is 0.50, and the standard error is also given as 0.052. So for the whole survey population, that is all the voters in ward 75N, we have to calculate the proportion of people that voted for BJP in that. Now, as we know that we have to find the mean of all the people, or in other words, the population mean, we can use simply central limit theorem, and we can say that mean of the sampling distribution is equal to the population mean. And as the question says that the sampling distribution mean is 0.5, the population mean also becomes 0.5 or 50%. Now similarly, let's say that you made a sampling distribution of Y as the proportion of people that voted for INC, and the mean of this sampling distribution is given as mu of x, which is 0.50, and the standard error is also given as 0.048. Now what we have to do is, for the whole survey population, that is for all the voters in ward 75N, we have to calculate the standard deviation of Y. Now as we know that population standard deviation is measured by sigma. Okay, now using CLT, we can say that sigma by square root n, which is the standard error, is equal to sigma by square root of 100, because n is equals to 100 over here, and the standard error is already given, so we will equate this equation by 0.048. Now the square root of 100, as you already know that it is 10, so what we'll do is we will multiply 0.048 into 10, so we'll get 0.48 or approximately 48%, which is our answer. Now this brings us to the end of the session on central limit theorem. Let me know if this content was helpful in understanding some of the related concepts and was able to solve all your doubts. If you have any further questions, please don't hesitate to leave it in the comment section. I will surely address them. Also, if you have not already subscribed to my channel and hit the bell icon, please do that, as I will be coming with more awesome content on data science in the coming weeks. In the next sessions, we will be covering some hypothesis testing concepts, so stay tuned. Until then, keep on learning. I will see you soon. Thanks and take care.